Okay, in this lecture we're going to discuss rational expressions. A rational expressions is any expression such as P over Q where P and Q are polynomials. Alright, and of course Q here cannot be equal to 0. In fact, the domain, which is the of the rational expression, is in fact determined by finding when in fact Q is equal to 0, and that will give us the values. Alright, this gives us the values that are not part of the domain. Right, so a simple example would be something like, say, 2x take 1 over x minus 3. Notice that this is a linear polynomial, or a polynomial of degree 1 over a polynomial of degree 1. Now notice in this case here, q is equal to x minus 3, and so we see that x minus 3 cannot be equal to 0, which implies that x cannot equal 3. So this tells me then the domain are all numbers except 3. So it's a set of x such that x is not equal to 3. And of course the way that we can actually write that in interval form is of course anything but 3, like so. Okay. Alright, so there is our domain. Okay, and we're talking about real numbers here. Okay, so the first thing that we want to do here in simplifying them, and that's our objective here, is to simplify rationals. So this is our first objective. Alright, simplify rational expressions. And we use a very important property here, which is the fundamental theorem, or fundamental principle of fractions, which says this. It says that if I have A over C, A times C over B times C, then I can write this as A over B. Okay. Now notice both B and C here can't be equal to 0. Okay. So notice that this is saying really that if I have a common factor in the numerator, which is the top part, and the denominator, which is the bottom part, then we can factor that out. So let's look at some examples of doing this. Okay, so let's this is called writing in lowest terms. Expressions in lowest terms. Alright, now notice it's lowest terms because we've factored out the C from the top and the bottom. Alright, so let's do part A. Right, so let's suppose we have 12x squared minus 24x over 4x squared minus 16, say. Right, so let's have a look here. So we start looking at the numerator and the denominator as separate entities to start with, and we look for common factors in here like we did in the last lecture. So we know there's a 12 in both of these, and we know there's an x in both of them. So I'd end up with x minus 2 here over, notice here we have difference of two squares, 2x minus 4 over 2x minus 4. Okay. Now, of course, here we could have, of course, a different way of looking at this would be we have this, and instead of doing that to start with, we want to take out a 4 first, and I'd have an x squared minus 4. So this would come down to be, notice we have 4's into here, goes 3. So I'll end up with 3x by x minus 2 over x minus 2 by x plus 2. Notice we can still go to lowest terms again because we have an x minus 2 in the top and the bottom. So I end up with 3x over x plus 2. Right, let's look at the next one. Let's suppose I have y squared minus 8y plus 16 all over 8y minus 2y squared. Okay, so again we start factoring everything we can. Notice that this one here, you should recognise we have a squared here, 4 squared, and 2 times 4 is 8. So this one will be a perfect square, like so, over, and of course we can take out a 2y here, and I'll end up with a 4 minus y here. Okay, so this would become y take 4 by y take 4 over, I'm going to take out a negative sign here, 2y, and the negative sign will allow me to spin this around like so. Notice we have 2y by negative 2y is negative 2y squared, exactly the same as what I have here. And we have 2y by 4 is 8y, so negative 2y by negative 4 is positive 8y. Now, of course, we have common factors here. So I'll end up with negative y take 4 over 2y. Now, to be absolutely clear about this, we should write it as y take 4 in parentheses right here, and of course there's a negative in front, over 2y. Okay, right. So that's the way we do these types of problems. Always treat the top polynomial and the bottom polynomial as separate, and factor as far as you possibly can, and then use the fundamental principle of fractions, all right, to actually get it into lowest terms.